What do you need to know about the periodic table? There are 18 columns on the periodic table. We refer to these columns as groups or families. We have 7 rows on the periodic table that we call periods. These two here, 58, 57, notice that's still the same, and 89 to 90 is still the same. So we only have 7, not 9 periods. Next, the tall columns can be replaced with the number and the letter A. These will be known as representative elements. Now, occasionally you will see Roman numerals replaced with the numbers. For example, if you look at 3A, if you see the Roman numeral 3 with A, it means the same thing as the 3A. Likewise, 5A, remember, is a V with an A. So don't be surprised when that happens. The next thing you need to notice are the lower columns. Notice this time there are B's. This stands for the transitional metals. The next thing you need to notice are family names. So let's start on the far right-hand side. 8A is also known as the noble gases. 7A are known as the halogens. 2A are the alkaline earth metals. A small part of 1A is known as the hydrogen family. The majority of 1A are known as the alkali metals. The central middle block are known as the transition metals. The 2 bottom rows are known as the inner transition metals. The top part of the inner transitional metals, marked in blue, are known as the lanthanide series. The bottom of the inner transition metals, marked in red, are known as the actinide series. And column 6A is also known as the chalcogens, although nowadays they go as the sulfur-oxygen family. Next thing you need to know, metals are outlined in blue. Characteristics, they're usually solids. In fact, most of them are except for one element, which we'll point out later. They're shiny, good conductors of electricity and heat. They're ductile, and they're quite malleable, which means you can hammer them into fine sheets. In red, I have the nonmetals. Notice that there's not as many of them. They are opposites of metals, so they are brittle. They're not malleable or ductile. They're poor conductors of both heat and electricity. They tend to gain electrons in chemical reactions. Some are liquids, but you do have some solids, and some are gases. So we have a little mixture of all of them. The remaining ones in green are the metalloids, sometimes called semi-metals. They have a mixture of between the metals and the non-metals. They are economically important because of their unique conductive property. We usually call them semiconductors. They have some similar properties, like I said, of both, but semiconductors is one of the big ones they usually look at. Most of the periodic table is made of solids. Notice where it's all outlined because I did skip out some places. The next in line would be the gases. Notice the gases in red take up pretty much the rest of the periodic table, but there are 2 spots that are not pointed out, and here they are. 2 spots in green are liquids at normal room temperatures. We have mercury and we have bromine. So as far as the solids go, when you talk about metals being mostly solids, well, mercury is my liquid, and in the nonmetals, bromine is the liquid in that case. The next thing is noting that everything in the periodic table has this number, a whole number in each box, which we call the atomic number. The whole periodic table is arranged by this, and no 2 elements have the same atomic number. The next thing you need to notice in each box has the atomic mass, which is the number you see at the bottom of the periodic table. That comes from the nucleus of all the versions of that element, which we like to call isotopes. But you will see another word called molar mass in your future, and molar mass comes from using that number, so try to remember that. It'll help you out a lot. The next thing is nuclear symbol. And of course, every box has one. If I look in here, there's that one. Of course, Fe stands for the element iron. So make sure you pay attention to the elements that you're responsible for learning. And that concludes what you need to know to the point of the periodic table.